All right, next up in Unit 10, Section 10.4 is called Reference and Coterminal Angles. So this is just a little bit more about angles and some of the things that we can do with angles before we get started talking about the unit circle, which is kind of the big idea in trig. So we're going to be finding two different things today based on angles that are given to us. We're going to find the reference angle. And the reference angle, the definition's up top here. You might want to write this down in your notes, or if you just have this picture with all four quadrants of the reference angles for each quadrant, that's probably fine too. But a reference angle is an acute angle. That's the important word there. Means an acute angle which is less than 90 degrees. So if you try to say that a reference angle is like 120 degrees, that would be wrong, because all reference angles have to be less than 90. So it's an acute angle formed by the terminal side of the angle in the x-axis. So basically, a reference angle is how far are you from either 0, 180, or 360. That's what a reference angle does for us. It tells us how far we are from 0, 180, or 360. I'm going to try that again. That looks a little better already. Okay. How far are we from either 0, 180, or 360? It's got to be an acute angle, so less than 90. If you're in the first quadrant, all angles in the first quadrant are less than 90 already. So however many degrees you've gone from the initial side is going to be less than 90. That's how far away you are from the x-axis right here. So anything in quadrant 1 is its own reference angle. If you're over here in quadrant 2, then basically what the reference angle is asking, or what the reference angle gives us, is how far away, how much further that angle would need to go to get to the 180 over here. Quadrant 3 is basically how much past 180 have we gone. So in this one, the example that they gave is a 240 degree angle all the way around there. So then the closest x-axis is 180 right here, and we have gone 60 degrees past that 180, so the reference angle there would be 60 degrees. And then for quadrant 4, down in this area, basically quadrant 4 asks us how much further do we need to go to get back to the x-axis, or in this case back to the 360, which would be where we started. So if this angle is 315 degrees, then the reference angle is this 45 that we have left to go to get back to 360. Okay. Some of them are in degrees, some of them are in radians. The degrees and radians parts, we're going to have to keep it in the same mode. So if it's given in degrees, you need a reference angle that's in degrees. If it's given in radians, you need your reference angle to be in radians. Okay. Coterminal angles are two angles that have the same initial and terminal sides. So it's two different angles that start and end in the same spot. There are actually, really technically, infinitely many coterminal angles, but we're going to kind of limit it to one that's positive and one that's negative. So this picture right here is an example of two coterminal angles. The initial side is over here. We're starting at the vertex in the middle, right? The initial side is over here on the right side. If you go positive 120 degrees like that, that puts you to your terminal side over here. Now, we're still starting off to the right here, but instead of going positive 120, if we go negative 240, that'll end in the same spot. So those are two coterminal angles right there. Positive 120 and negative 240 are angles that start and end in the same spot. Another one to think about would be like 370, one of the angles that we talked about in 10.3, right? 370 degrees was a full 360 plus an extra 10. So 10 degrees and 370 degrees are also coterminal angles because they start and end in the same spot. They don't necessarily go the exact same direction or the same amount of times around the circle, but 370 and 10 are coterminal angles because they technically start and end in the same spot. What happens in the middle doesn't really matter. So we're going to start with reference angles. It says in the directions, keep the angle in the given mode. That means if your angle is given in degrees, the reference angle would need to be given in degrees. So on numbers 1 through 5, oh, I guess I kind of covered that up with my head there, didn't I? So On numbers 1 through 5, the angles are given in degrees. So we're going to ask ourselves, are we closest to 0, 180, or 360? And we're going to ask that about all the angles that are given to us in degrees. So for 30 degrees, are we closest to 0, 180, or 360? Well, we're closest to 0. How far away from 0 are we? 30 degrees is quadrant 1, so your reference angle for that is its own 30 degrees. Then for 260, are we closest to 0, 180, or 360? On number 2, for 260 degrees, that's closest to 180 degrees. How far away from 180 is it? Well, if we take 180 plus another 80 degrees, that gets us to 260, so our reference angle would be 80 degrees. Now, even though the angle is negative, since we're talking about how far away we are, it doesn't matter if it's positive or negative. So even though it's negative 135, we're still asking are we closer to 0, 180, or 360? Well, we're closer to 180. How much further do we need to get to 180, or how far away from 180 are we? 135 plus another 45 gets us to 180. Even though it's negative, doesn't matter. We're talking about distance here. We always measure distances as positive values. Number 4, 460 degrees. So are we closer to 0, 180, or 360? Well, technically we're closest to 360, right? But 460 is 100 degrees away from 360, which means that it's not an acute angle. And remember, we said reference angles have to be acute angles. So if we keep going with that same pattern, closest to 0, 180, 360, if we add another 180, so basically we're going half times around the circle, right? So 0 is on the right side, 180 on the left, 360 back on the right. If we go one more time around to the left, that's going to be 540. And we're actually 80 degrees away from 540, so your reference angle would be 80 degrees. Last one, number 5, we're closest to 180. It's 20 degrees away from 180, so your reference angle is 20. Now, the ones that are in radians become maybe just a little bit more difficult because we have to think of it in terms of pies instead of degrees, right? So 0, 180, 360, basically that's the same thing as 0 pi, 1 pi, or 2 pi. So if we think of pi over 4 as 1/4 of a pi, you have one piece out of a pie. Let's think of it this way. If we wanted to draw a little picture here, we know that each pie is half of a circle, right? If we divide it in fourths, we have one piece out of 4. Are we closer to having no pie, 1 full pie, or 2 full pies? We're closest to no pie, so our reference angle is going to be pi over 4. Moving on, number 7. We know that a full pie this time has 6 pieces in it since it's pi over 6. Oh, I didn't do that right. So we need to cut our pie into 6 pieces here. Even though it's negative, doesn't matter. We have one piece out of pi over 6. Remember, we've got 1, 2, 3, 4, 5, 6 pieces here. Are we closer to having no pi, 1 pi, or 2 pies? We're closest to no pi, 0 pi, I guess. How far away from 0 pi? Well, we have one piece of our pi over 6. Number 8, same kind of thing. Draw the picture if it helps. This time we need to cut our pie into 3 pieces. I'm not very good at cutting pie, obviously. Look at that. This time we have 2 out of 3 pieces of pie here. So are we closer to having no pie, 1 full pie, or 2 full pies? We're closest to 1 full pie. And so how far do we have left to go? We have one more piece left to go to get to a full pie, so that would be pi over 3. Moving on over, question number 9. We have 5 pi over 6 this time. So let's draw our pi, which is a half circle. I need 6 pieces. And the angle that we have is 5 pi over 6s. So here's 1, 2, 3, 4, 5. So are we closer to having 0 pi, 1 pi, or 2 pi? Closer to having 1 pi. We have one piece left to go to get to a full pi, so we need a pi over 6. Bam. Last one, number 10. This one, oh man, this one's all kinds of crazy. Okay. Here's 1 pi. We have 15 pi over 4. So here's 1, 2, 3, 4 pieces. We need to do another pi. 1, 2, 3, 4. So that's 5, 6, 7, 8. Here's another pi divided into 4 pieces. We have 9, 10, 11, 12. So here's another full pi. This one kind of stinks, doesn't it? So we were at 12, so here's 13, 14, and 15. So we have all of that. How much do we have left to go to get to our nearest full pi? We've got this one little piece left over, which is pi over 4. Here's what I want you to notice, and this is a little bit of a shortcut that probably works about 95% of the time. No matter what the number is on the top of the fraction, this one was a 1, this one was negative and a 1, this one had 2, this one had 5, this one had 15. Now, this is not necessarily going to be the case every single time, but like I said, about 95% of the time, the denominator stays the same. Boom, 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 boom. The denominator stays the same, and then it's just a pi on the top. 95% of the time that's going to work. So if you want to roll with that, roll with that. Just make sure you're thinking about how close are you to having a full pi on some of those when it's radians, okay? So for coterminal angles, in order to find one positive coterminal and one negative coterminal, we actually have a very easy way to do this. We just need to add to get the positive one and then subtract to get the negative one, but we're going to add and subtract one full rotation around the circle. So if we want to be in the same spot as 60 degrees, another way to do that would be to add 360 more or take away 360 more. So that's how we're going to do it for degrees. We'll talk about radians here in just a second. We have 60 degrees. So we're going to do plus and minus. And so kind of notice that I'm putting both of those there. We've got plus and minus 360 degrees. So to start off, we're doing 60 plus 360, which would be 420. Then we do 60 minus 360, which is negative 300. There's going to be 2 spots for you to put these in on Canvas. The way that I want you to format it is to put your negative angle first and then your positive angle second. So the 2 that we have here, and I forgot to put my degree symbols, you don't need to put the degree symbols in Canvas. You're just going to say negative 300 and 420 are the 2 angles, and that's how you would format it in Canvas. Negative 300 and 420. So number 2, we have negative 150 degrees this time. We're going plus and minus 360. So negative 150 plus 360. Use a calculator if you need to. That one's 210. And then negative 150 minus 360. You're going to get negative 510. So putting the negative 1 first. So maybe we should really just subtract both times, right? Or subtract first and then do the other one. So negative 510 and your positive one is 210. There you go. Go ahead and pause the video right here. Try number 3 on your own for 200 degrees. We're adding and subtracting 360. I'm going to subtract first this time because it makes sense if we want the negative one first, right? So 200 minus 360, we've got negative 160. And I actually don't want the degree symbol when I do Canvas, okay? And we do 200 plus 360 to get 560. So negative 160 and positive 560 are your 2 coterminal angles for number 3. We've done enough of those. I'm going to skip this one right here. Let's go on to, oh no, I thought we were going to have, oh, no. Darn it, I wish I had one that was like this. Okay, we're going to change this one here. And we are going to make number 5 be 400 degrees. So change number 5. We're going to do example number 5. We're going to make that 400 degrees. So what I want you to notice here is that when we add and subtract 360, Do this one, well, either way you do it. So do the subtraction one first. So 400 minus 360. But notice that we don't get a negative one. 400 minus 360 is positive 40 degrees. Then if you do 400 plus 360, you get 760 degrees. Neither one of those are negative, and the directions say that we need to have one that's positive and one that's negative. So what we're actually going to do then to find one that's negative is, since we already subtracted 360 once, let's go ahead and subtract 360 again. So I'm going to take the smaller of the two and subtract 360 again. That's going to give us negative 320. And then I would actually probably use this one. So negative 320 and 40. You could also use negative 320 and 760. I think Canvas is set up to where it would take either one of those as the second one, as the positive one. So as long as you do need to have the negative 320 in the first box, and then I think it would take 40 or 760 as the second one, either one of those. So now we need to talk about if we are doing radians. So we're adding and subtracting 360 when it's degrees, right? Well, what can we add and subtract that would be the same thing for radians? Well, we know that 360 degrees, or one full time around the circle, is 2 pi. So what we're going to do with these ones is we are going to add and subtract 2 pi. Since these are fractions, that makes it a little bit more difficult, though, because in order to add and subtract fractions, we have to have common denominators. So I'm going to make this 1 pi over 4. We're going to add and subtract something with a decimal of 4. So the way that we're going to do this, you can think of this as 2 pi over 1. Since we want the denominator to be 4, that means I have to multiply the top and bottom by 4 on this fraction. So we're actually going to be adding and subtracting 8 pi over 4s, which makes sense. If each pie has 4 slices, how many slices do you have in 2 full pies? 8 pi over 4. So then all we really have to do is just add and subtract the numerators to find our answers, right? So I'm going to do the negative one first. We have 1 pi minus 8 pi, which would be negative 7 pi over 4. And then for our positive one, when I add 1 plus 8, we're going to get 9 pi over 4. And there's your 2 this time. So then for pi over 3, I'm going to go ahead and make the common denominator right now so we don't have to rewrite it. We have negative 1 pi over 3. This time we need to add a denominator of 3. So I'm multiplying, if we think of this as 2 pi over 1, I'm multiplying the top and bottom by 3. Or if each pie has 3 slices, how many slices are in 3 pies? So we're adding and subtracting 6 pi over 3's here. Negative 1, I'm going to do the subtraction first, so I get the negative first, right? Negative 1 minus 6, we have negative 7 pi over 3. And then we add to get the positive one, so negative 1 plus 6 is going to be a positive 5 pi over 3. All good stuff so far, I hope. Go ahead and pause the video right here. Do number 8 on your own, please. Notice that the denominator is the same there on number 8. So you're going to be adding and subtracting 6 pi over 3 again. Go ahead and pause the video right here and do that. So hopefully you subtracted first. You did 2 minus 6 to get negative 4 pi over 3. And then we add 2 and 6 to get 8 pi over 3. And those would be your 2 coterminal angles there for number 8. Number 9, same kind of thing. We're going to go ahead and skip it. I don't think we need the extra practice on that one because we're just adding and subtracting. 12 pi over 6, not 8. I don't know why I wrote that. So you should end up with negative 17 pi over 6 and positive 7 pi over 6. Add and subtract the numerators. Same thing that we did before. The one I do want to talk about is number 10, though. Okay, number 10 is kind of similar to the one that we did up top there. If we just add and subtract our 2 pi, so with a denominator of 4, that would be 8 pi over 4. Notice that the first one we get when we do 15 minus 8 is going to be 7 pi over 4. And then when we add these together, we get 23 pi over 4. Both of those are positive. We need there to be a negative one in there somewhere. So just like we did up top, I'm going to actually subtract. So I'm going to actually, well, when we subtracted and we didn't get a negative one, forget about adding them. I'm just going to have to subtract 8 pi over 4 again. So then we can get 7 minus 8 and get negative 1, or just negative pi over 4. And then you can use the 7 pi over 4 here. I think it would also, if you went ahead and added them and you put 23 pi over 4 as your positive one, I believe Canvas would take that as a correct answer also. You just have to have the negative one first, and then you can have either of these two at the end. Same thing with the degrees ones. You have to have the negative one first, and then it'll take either of those two positive ones as a correct answer. All right? So reference angles, how far away are you from 0, 180, 360? Or how far away from you are to the closest full pi? Coterminal angles, adding and subtracting either 360 degrees or adding and subtracting 2 full pi's and making sure that you have a common denominator first. Your 10.4 practice is on Canvas. It's not due until next Tuesday. Next week is state testing week for sophomores, so sophomores, make sure you're ready to go. Freshmen, you guys are going to be map testing next week. Juniors and seniors, you guys will be doing some ACT prep and an ACT math practice test in class on Monday, Wednesday, or Tuesday, Thursday. Let me know if you have any questions, and enjoy your weekend.